Hi, my name is Nicolette Maggiore, and I'm a student at Rutgers University, New Brunswick, studying chemistry with a concentration in forensics. My work in the REU program at North Dakota State University is assessing green chemistry knowledge in the organic chemistry classroom. Green chemistry is another word for sustainable chemistry, and it looks at preventing and also minimizing hazardous waste and toxicity of chemicals in chemical processes. So why is this important for students to be learning in the classroom? It starts bridging the gap that exists between academia and industry, and it allows students to look at the different factors of sustainability and observe their relationships and see how they work together as a system rather than just looking at them individually. And so we hoped that we'd be able to see how well students can apply their understanding of the 12 green chemistry principles to answer some different types of assessment questions. And so the first type of assessment students were given was a 12-question true or false online survey. And the second was a bonus open-ended exam question in which the students were given two different reactions and asked to determine which one was more green and why. And so by using these two different assessments, we hoped that we'd be able to refine our true-false assessment to better suit student language and student vocabulary. And we also hoped we'd be able to take the open-ended responses and explore student reasoning and explanations. And so when looking at the true-false assessment results, classical test theory was done, rationalysis as well, and rationalysis allowed us to plot student ability on the same scale as item difficulty, which was really beneficial in seeing which item students struggled with the most. Students were also asked their interest level on a Likert scale 1 to 4 of green chemistry and how interested they were in it. And what we ended up seeing was that there was no correlation that exists amongst interest level and knowledge level of students. And so when looking at the open-ended assessment results, student responses were open-coded to 6 themes that were reflective of the principles of green chemistry. And then further, the responses had overlapping themes, and so that is represented as well and further analyzed. Students were able to mostly determine the correct reaction as reaction A is to being more green than reaction B. And so as a result, the open-ended assessment is sufficient in eliciting student understanding and student reasoning. And the true-false assessment needs some refinement on the language use. Student mentioned terms like facile degradation and halogenated molecules, so just working through how we can make those questions more accessible to students. Also, we'd like to refine the interest level scale and make it more specific. That way we have a better understanding of student interest, and maybe we will be able to then observe some correlation. So I'd like to thank Alexi and the whole cohort for being so wonderful and giving me this opportunity. Thank you all.